Alright, so this is page 24, FLP 24 on the quads. Let's go through this real quick. Directions: complete the family tree using the words parallelogram, rhombus, square, rectangle, and trapezoid. So let's look and see where they would go. Phone's blowing up again. Here we go. So you got the quads. Up there's the words that we're going to use. So what I like to do is look at what's happening right here. This quad's out by itself, not really connected to anything but the quads. This one right here starts a connection between a bunch of other blocks. So here's what I like for us to do. We know that the trapezoid's kind of out by itself. So let's put him right here. And over here is our family of parallelograms. And parallelograms have two pair of parallel sides. So let's go ahead and start right here with our rhombus. And over here our rectangle. And right below that, this is connected to both of these, would be our square. Okay, got some questions down at the bottom. Circle always, sometime, or never to complete the following sentences. A rectangle is blank, a quadrilateral. A rectangle is going to always have four sides, therefore it's always a quadrilateral. Okay, because the only attribute to be a quadrilateral that you need to have is to have four sides. Okay. All right, let's keep going here. A trapezoid is always, sometimes, or never isosceles. Sometimes it doesn't have two congruent sides, and that's what causes it to be isosceles, is when it has two congruent sides. Okay. A quadrilateral is always, sometimes, or never a rhombus. Well, some quadrilaterals are rhombus, but not all of them. So we're going to circle sometimes right there. Then the next one, number 4, a square is blank, a rectangle. Okay, this one gets a little confusing. A square can always be considered a rectangle because in order to be a rectangle, you just have to have two pairs of parallel sides of 4 90-degree angles, which a square has, so we can always consider it a rectangle. Okay, and the only reason we call it a square is when it has 4 congruent sides. Now, we didn't say a rectangle was a square, we said a square was a rectangle. Always. A trapezoid is always, sometimes, or never a parallelogram. Okay, parallelogram has to have two pair of parallel sides, and a trapezoid only has exactly one pair of parallel sides, so it's never a parallelogram. And if you look at the map up top, notice the trapezoid is not part of the parallelogram family. That kind of helps to understand that. A rhombus is blank, always, sometimes, or never a quadrilateral. Well, a rhombus has to have 4 sides, so it's always going to be considered a quadrilateral. And number 7, a trapezoid is blank, always, sometimes, or never a rectangle. A trapezoid only has exactly one pair of parallel sides. In order to be a rectangle, you have to have 2 pair of parallel sides, so it is never considered a rectangle. Cool, let's jump over to FLP 25, see what we got here. Alright, it says side lengths and angle measures of quadrilaterals, part 1. Use the properties of quadrilaterals to find the value of angle H and line segment FG. Kind of going back into those similar figures that we did last week. So let's look at what we have going on. Looks like a parallelogram here. These two arrows match these two arrows, means these two lines are parallel. It means they run forever without intersecting. Notice there's one arrow here and one here. That means those two lines are parallel, okay? Then they give us a 55-degree measurement of this angle. And down here they call this angle Y. Yes, I'm not sure why they have the Y there, but maybe it'll pop up. What type of quadrilateral is illustrated in the figure? Two pair of parallel sides is going to be a parallelogram. Okay? If that side, and that were congruent, we'd have a little tally or tick marks, whatever you want to call them on there. I'll show you that here shortly. So it says, what angle does angle H correspond to? Well, when we're talking about angle H here, we're corresponding, meaning opposite going here. It's kind of the matching angle, and it's going to be 55 degrees, but we'll put the angle H corresponds to angle F. Okay? All right, let's keep going. Number 3 says, what side does FG, or line segment FG, correspond to? Well, if you look, FG goes right here, which corresponds to JH. Okay? So let's put our line segment J, H right there. Okay? So it says, how can you find a missing side link and missing angle measure? Explain. 2 statements we got to write right here. Okay, let's put a dot. And this is where we start learning what's happening between these things. Since this is a parallelogram, any parallelogram and all parallelograms, opposite angles are congruent. Okay. And then the next statement is that any and all parallelograms opposite sides are congruent. Okay? So if we look at these 2 statements, we know that angle H has to match angle F because they're opposite angles and they're congruent. So we know angle H has to be the same, which is 55 degrees. And line segment FG, opposite sides are congruent. If you go opposite of FG, you've got JH, which both of them would be 13. Doesn't give us a unit measurement there, so we'll leave that one like it is. Okay, hey, let's jump to 26. I think we got time to knock that one out too. It's not too bad. Very similar to what we just did, we got a different figure this time, okay? So it says side lengths and angle measures of quadrilaterals part 2. Use properties of quads to find the value of angle A and the value of X. Well, look, they got 2X, so they're probably going to end up giving us an equation here, which is no big deal. What type of quad is this? Everybody recognizes that that's a square. And here's the marks I was talking about. These things right here, since there's 1 on each side, all those 4 right there mean that all 4 sides are congruent or equal. Okay? And when you see those, you know that all 4 sides are going to be the same. It says, what angle does angle A correspond to? If you look at it, it's angle C. Then it says, what side does line segment DC correspond to? Line segment AB. Okay? Then number 4 says, how can you find a missing side length and missing angle measurement? Well, let's write a couple of statements again for a square. Okay? We know that for this to be a square, all angles are congruent. That means they're the same. All 4 angles are the same in every square. They're 90 degrees. Okay? And also the next statement is that all sides are congruent. Cool. That helps us to figure out that angle A is equal to, well, if you look up there, that's a 90-degree mark, so we know it's 90 degrees. Now X, this is a little fishy here, okay? So let's look at something. I'm going to write something over here. If we know that one of those sides is, I think it's 2X, and the opposite side to that is 9, this has to be equal to that. Notice I put an equal sign in between them. So what we do is just solve for X. They want the value of X, not the value of the side. We know the side's going to be 9. All we have to do is something we learned way back in 6th grade is a one-step equation. And with a handy dandy calculator, you find out that that's 4.5. Okay? Now let's look at 6. If CA, line segment CA, is about 13 units, what other length can you determine? We can determine that line segment DB, which is diagonal, okay, is about 13 also, because listen, in a square, here's another statement we can write, diagonals are congruent. I'm slowing down again. Okay, and then it says number 7, how many lines of symmetry are in quadrilateral? If you remember the page we did, I think it was on the last video, we know that there are 4 lines of symmetry, not in every quadrilateral, but in a square. And that's the figure we're talking about, okay? All right, there's all the way through page 26. Thanks for watching this one. I'll catch you on the next one.